Hey everyone, it's Mr. Glover here. So yesterday we talked a bit about graphing exponential and log functions, and we transformed the logarithmic function. Today we're going to kind of take a step back to where we were. We're going to work with logarithms to solve equations. Okay, so now that we have the log laws, we've got a lot more in our tool, or we have a lot more power in solving equations because we can actually solve for the exponents now instead of being stuck with using guess and check or graphing to do that. So now that we have the logarithm to work with, exponential equations, we can use it to solve a variety of equations. Key ideas when working with exponential or logarithmic equations. First one, whatever you do to one side of your equation must be done to the other sides or to both sides. You can always convert between the logarithmic form and the exponential form of an equation, if that helps. Log base a of x and a to the x are inverses. Don't forget to use the log laws, and you're going to need to use the power rule to pull x out of the logarithm. And then lastly, don't forget that you can change the base of any logarithm. All right, so we'll be working with three main types of exponential or logarithmic equations. So type A, we're going to need to use log laws to simplify and solve the equations. Remember though that logarithms have restrictions, so we need to check our restrictions. You can do that at the start by keeping a tally of what's allowed and what's not. You can also do that by testing answers once you get to them. So let's take a look at this question. 2 log x equals log 36. We need to solve it in two different ways. So the first way we're going to do it, we're going to convert to exponential form. So if we start by just writing our equation, 2 log x, let's zoom in a little bit here. 2 log x equals log 36. Okay, I'm going to then move the 2 up into my exponent. So I'm going to call the right log of x squared equals log of 36. And now I'm going to convert into exponential form. Basically, I can say that x squared equals 36. I take the square root of both sides. X equals the square root of 36. And I'm left with x equals plus or minus 6. This is where the restrictions come in. If you go back, your original log was just log of x. You're not allowed negatives and you're not allowed 0. So because there are no negatives allowed, no negative x, we can kind of cut this answer in half, and now we're stuck with just x equals positive 6 as our answer. If you have time, you can always go and plug this back in and double check that it works. But that's going to be our answer for now. Let's do this a different way. Let's do this without converting. So let's go 2 log x equals log 36. Okay. I'm going to move the 2 to the other side. So log of x equals 1/2 log of 36. And now I'm going to move the 1/2 into my exponent. Log of x equals log of 36 to the 1/2. We can now take the square root inside the logarithm. Log of x equals log of 6. And if we have that a log of something equals log of 6, well, I think it becomes pretty obvious that something must be 6. And we get the same answer. So there's two ways of solving this. There's probably other ways of doing it as well. It just shows you that once you have these log laws, they just become part of the algebra in solving an equation, and you've got some freedom in how you want to do it. So let's try another question. Let's try this question A here. So log base 2 of x plus 3 all squared equals 4. All right, I'm going to remove the 2 first, and I'm going to write this as 2 log base 2 of x plus 3 equals 4. I'm then going to divide by 2. So log base 2 of x plus 3 equals 4 over 2, or log base 2 of x plus 3 equals 2. At this point, I'm going to convert into exponential form. If you remember, it's which power of my base is the argument, and the answer is 2, so that tells me that 2 to the power 2 has to equal the argument, x plus 3. The base to this power equals x plus 3. So I get 4 equals x plus 3. If I subtract 3, I get x equals 1. We can go back and double check, does this work? If I put 1 in here, I'm going to be taking the logarithm of 4. That's okay because there's no negatives or no zeros. Okay, let's try another one. Log base 3 of x squared plus or minus 8x to the power 5 equals 10. This one looks pretty ugly until we get rid of our exponent. So the first thing I'm going to do is move this 5 out front using the power rule. So I'm going to write this as 5 log base 3 of x squared minus 8x equals 10. You can now divide by 5. So log base 3 of x squared minus 8x equals 2. We can now go to exponential form. This base to this power must equal the argument. So 3 squared has to equal x squared minus 8x. 9 equals x squared minus 8x. Or 0 equals x squared minus 8x minus 9. All right, and look at this. We've got a quadratic equation. It's like two of your favorite things all joined into one, logarithms and quadratics. So hopefully this is one we can factor fairly easily. I think it is. We need two numbers that multiply to -9, yet add to -8. We could go with -9 and 1. That would work. So 0 equals x minus 9 times x plus 1. And our answers are going to be x equals 9 or x equals -1. If we go back in and check these answers, if we put a 9 in here, 9 squared minus 8 times 9, that's going to be positive, so that'll work. If we put a -1 in here, we're going to get minus 1 squared, which is 1, minus 8 times -1, which will be positive 8. So it's like 1 plus 8, which is positive 9. Both of those are allowed. We don't have any zeros, we don't have any negatives, so this is going to be our answer. Both work. All right, we've got a couple more of these to do. These are going to get a little bit uglier. So now we've got 3 terms, 2 logs and 1 constant. What you should do if you see something like this is try to join your logs together if at all possible. So I'm going to subtract this logarithm to the left-hand side. I will get log of 8x plus 4 minus log of x plus 1 equals 1. Now I can join these together using the log law. So if we're subtracting, this just becomes a denominator. So I can write this now as log of 8x plus 4 divided by x plus 1. This equals 1. And now I need to try and see if I can cancel out any terms. It doesn't look to me like it's going to work. If this was 4x plus 4, I could pull a 4 out and cancel out x plus 1. Unfortunately, I can't do anything. I know it's tempting to cross the x's out. I know some people would normally try and do that, but you can't do it, and it's not actually going to work. But what we can do is we can use exponential form. So let's convert this into exponential form. This is base 10, so 10 to the 1 has to equal the argument. So that means 10 to the 1 has to equal 8x plus 4 divided by x plus 1. And now we get to go about simplifying this. X plus 1 times 10 is going to give us 10x plus 10 equals 8x plus 4. We might be able to escape the quadratic formula this time. Subtract 8 and subtract 10 is going to give us 10x minus 8x is 2x equals 4 minus 10, which is negative 6. Or x equals minus 3. Okay, so let's test this. If we were to put minus 3 in here, 8 times minus 3 is going to be negative 24, plus 4 is still negative 20. Not going to work. Same with this one. Minus 3 plus 1 is minus 2. It's negative, so it's not allowed. So this doesn't work. So this particular question has no solution. Make sure you double check. Oftentimes I'll see on something like a test, people will go through everything and do it all 100% right, but they'll forget to check their answer, and then their answer won't actually work. And they'll say that minus 3 is the answer when in fact there is no answer. All right, let's try another one. We're going to use the same kind of process to solve this. We've got two logs, they're the same base, we can join them. So we join them using the product rule. We can write this as log base 6 of x minus 3 times x plus 2 equals 1. And then I could expand these brackets out. I could do it now or I could do it later. I'm just going to leave them for now and write this in exponential form. So 6 to the power 1 has to equal the argument. X minus 3 times x plus 2 has to equal 6 to the 1. Now we're kind of stuck expanding our brackets, so we've got to do some FOIL, first, outer, inner, last, and we will get x squared minus 3x plus 2x, so minus x minus 6 equals 6. And then we need to move our 6 over. I think you can see where this is going. We're going to get a quadratic equation on our hands. Minus 6 from both sides, we'll get x squared minus x minus 12 equals 0. And now we need two numbers that add to minus 1 and multiply to minus 12, which is going to be minus 4 and plus 3. So x minus 4, x plus 3 equals 0. So if we make these brackets 0, we have two options. X is going to equal positive 4 or x is going to equal negative 3. So we've done the heavy lifting. Now we just have to go back and test our answers. If we were to put minus 3, I'm not so worried about the 4 because 4 minus 3 is positive and 4 plus 2 is positive, but I am worried about the negative one. Minus 3 is going to get us negative 6. Can't have that as an argument in your logarithm. So that answer is off the table, and x equals 4 is our only solution. All right, let's try some more of these. They're starting to get a little bit uglier here. Now we have 3 logs to deal with. We can still solve it using the same sort of approach, though. We're just going to have to join these together, at least as many as we can. So let's zoom in a little bit. What I'm going to do is I'm going to join the left-hand side together and simplify it so I just have log of something equals log of 2x minus 3. Then I can scrap the logarithms and I can just work with the arguments. And then we can solve for x. So let's give it a shot. We need to move the 2 into our exponent first. You can't join them together until you've done that. So we can write this as log of x squared minus log of x plus 2 equals log of 2x minus 3. Now we join these together. This is being subtracted, so it's a denominator. So the left-hand side is log of x squared divided by x plus 2. This is going to equal log of 2x minus 3. And so at this point, we can scrap the logarithms. Technically, we're converting into exponential form, but log of a equals log of b means that a must equal b. So x squared over x plus 2 has to equal 2x minus 3. There's no other way. It'd be like saying log of x equals log of 2. Well, x is 2. And now we are going to have to join these together. Unfortunately, it's probably going to turn into a quadratic equation. So multiply by x plus 2, x squared equals x plus 2 times 2x minus 3. This will simplify into x squared equals 2x squared outer minus 3x plus 4x, so plus x minus 6. We're almost done. We need to move everything to one side, factor it. So we're subtracting x squared. 0 equals x squared plus x minus 6. All right, we can now factor this. 0 equals x plus 3 times x minus 2. And we now have our options for answers. Our answers are going to be x equals -3 or x equals +2. We've got to go back to our original question now. And let's just use the first log because that's going to be an easy one to test out. Log of 2, that's allowed. Log of -3, that's not allowed. So because this gives us a negative argument, our only option is that x must equal 2. All right, we'll do a few more of these. I don't know that we'll do every question in this. Log base 6 of x plus 3 plus log base 6 of x plus 4 equals 1. Okay, so let's join these together just as we've done before. So log base 6 of x plus 3 times x plus 4, that equals 1. Let's go and convert this to exponential form now. And we get x plus 3 times x plus 4 has to equal the base of 6 to the power of 1. We have to FOIL our brackets out, so x squared plus 4x plus 3x plus 7x plus 12 equals 6. We have to move the 6 back to the left-hand side, so x squared plus 7x plus 6 equals 0. And we can factor this. Two numbers that add to 7 but multiply to 6, that would be x plus 6 and x plus 1. 6 plus 1 is 7, 6 times 1 is 6. And so now we've got two options. We can have either x equals -6 or x equals -1. And you might be thinking, well, what if we can't have negatives in our arguments? You're allowed to have a negative for x, but the whole argument can't be negative. So if we plug -6 in, -6 plus 3, that gets me -3. That's negative, it's not going to work. However, -1 plus 3 is 2. That's allowed. -1 plus 4 is 3. That's also allowed. So x equals 1 is our solution in this case. All right. B, use logs to solve exponential equations with different bases. So this is a different kind of question. These are some trickier questions. I think we're going to do two of these. So we'll do the first two, and we probably won't do the second two, just because I want this video to be a reasonable amount of time. So for these kinds of questions, we're going to start with the exponential form, and we're going to have to use logarithms to work backwards and solve it. This is sort of the reason why we started with logs in the first place. These are the kinds of questions we couldn't solve before. So let's try this one. 4 to the x equals 605. Right away, I'm just going to take the log of both sides. It's an operation that I'm allowed to do. Just like I'm allowed to add 5 to both sides, I can take the log of both sides. So I can say log of 4 to the x equals log of 605. Now I've got the power to move x out of my exponent. So x log 4 equals log 605. And this log 4 is just a number. It's just going to work out to a decimal. So I can move it around as if it were a constant. I'm just going to divide by it. So x equals log of 605 divided by log of 4. That's something you can do in your calculator. And now we know that x equals 4.62. If this wasn't a base 10 log, you're probably going to have to convert it into a different base log in your calculator, which means you'll have to do the top and the bottom as separate calculations. All right, this question. These are ugly questions, and these are the kinds of things that really test your ability to use logs to solve equations. These are the kinds of questions that I would normally put on the long answer part of the test, because this gives me a really good indication of whether you know how to use the log laws or not. It's going to take quite a few steps, but it's going to be the same idea. We're going to take the log of both sides. We're going to pull our exponents out. Problem is when we do that, we're going to end up with a lot of terms that need to be sorted and need to move. We're going to need to move some to one side of the equation and some to the other. So let's give this one a try. Right off the bat, let's take the log of both sides. So the log of 4 to the power 2x minus 1 equals the log of 3 to the power x plus 2. And now we're going to move our exponents out using the power rule. So 2x minus 1 times log of 4 equals x plus 2 times log of 3. And now this is where people often get stuck, is this next step. This is by far the most common thing that I see. People will often divide by one of your brackets with x, so you'll get like 2x minus 1 divided by x plus 2, and you'll get stuck because you can't solve for x in that case. So what you have to do is you have to expand your brackets out. You're going to end up with a lot of terms. 2x times log 4 is the first one, so 2x log 4 minus 1 log 4. Do the same thing on the other side. X log 3 plus 2 log 3. And now we've got a term on both sides with an x in it, and we've got a term on both sides with no x in it. We're going to move everything with x to one side and everything without x to the other. So I'm going to move the x's to the left and the non-x's to the right. So the left-hand side is going to become, oh, that's a highlighter. The left-hand side is going to become 2x log 4 minus x log 3 equals 2 log 3 minus, or I guess plus log 4. All right, so now you've got options on how you want to solve this. You can go ahead and turn this into a decimal. You'll get an answer that's a little bit less precise, but it definitely will still work, okay? If you don't want to, you can leave it all as separate terms and just punch the numbers into a calculator once at the end. That's what I'm going to do. So now we're stuck with this task of trying to solve for x. And we've got two terms with x in it. What we have to do is we have to factor out an x. This term has x, this term has x, so let's just remove it. Let's factor it out. X times 2 log 4 minus log 3 equals 2 log 3 plus log 4. We're almost there. This is just a constant. That's just a number. We can treat it like 4 or 5 or 6, so we can just divide it. I can now divide this entire expression, and we can go x equals 2 log 3, oops, 2 log 3 plus log 4 divided by 2 log 4 minus log 3. If you want to, you can join these into one log. You can use the quotient rule. You can use the power rule here. It'll look nicer if you do that. It might be easier to put it in a calculator if you do that. You can also just type this whole thing in and solve it in one shot. You can do the top and the bottom separately. You've got a lot of options how you want to solve this. But if you're able to just do it in one calculation, that's going to give you the most precise answer. And that's what I usually recommend. So if you do that, you will get x equals 2.14. If you go on and take much more math and physics, there becomes a point where precision starts to matter, and you do actually need to make sure you don't round things until the end, or else your answers are going to be quite a bit different than the actual answers. All right, I think we'll skip these ones just in lieu of time. I want to do a couple questions on the last page because those are going to be a different technique or a different type of problem to solve. Give these ones a shot if you want. They are on your own questions. I think they would be a good starting point to practice this stuff. Question C, changing the bases of logs. So this is the third type of problem, and it's not necessarily the harder of the three. It's just different. So we need to calculate a logarithm that we don't actually have in our calculator. Some of you with the fancy calculators, you might be able to do this, but most of us don't. So we can simply use the change of base formula to just rewrite this log. If we want a log base 10, well, let's just do log of 40 over log of 3, and now it's a log base 10. That's something we can just put in our calculator, and we'll get 3.36 equals x. It can get more tricky than this, and the next question is an example of that, where we've got two different types of logs with different bases, and we need to somehow solve them, okay? Log base 2 of x plus log base 4 of x equals 6. We need to access the x, the argument, but the problem is we can't join these logs together because they've got different bases. So we're kind of stuck. We have to use the change of base formula in order to solve this question. So we can do that. Log base 2 of x can be written as log of x divided by log of 2. And log base 4 of x can be written as log of x divided by log of 4. And that's going to equal 6. Okay. We can do this a few different ways. If you can turn this into 2 squared, pull your 2 out, and then you'll have log of x and log of 2's. We don't really have to do it like that. We can just leave it like this. So what I'm going to do is I'm going to factor log x out, and this is going to probably seem kind of weird, okay? I'm just going to write this as log of x times 1 over log 2 plus 1 over log 4. And that's going to equal 6. What I've done is I've just pulled the x, or log x out, and if I were to multiply it back in, this will now become the numerator of both of my fractions. All right, so now log x is going to equal 6 divided by 1 over log 2 plus 1 over log 4. This is the point where you might want to think about calculating this and turning this into a decimal, because the next equation I'm going to write is going to be quite an ugly one and something that's not going to be very easy to put in your calculator. But it is possible, it is doable. If this is base 10 and we want to solve for x, what power of the base is the argument? This is your answer. So we know that 10 to, or actually maybe I'll give myself a bit more space. We know that x must equal 10 to the power 6 divided by 1 over log 2 plus 1 over log 4. This is just a number. This is the power of the base that the argument equals. Now we've got the challenge of putting this in our calculators. You can do it in multiple steps. You could simplify it over here. It's completely up to you. But the earlier and the more times you round, the less precise your answer is going to be. You should end up with x equals 16. So if you think that this is a little bit confusing, what I would suggest you do is at this point, write this as 2 squared. Pull the 2 out and then join these logs together. And then you'll end up with a much, much less ugly expression. Anyways, this is where I think I'm going to stop for now. We've gone through quite a few problems, and this is definitely a section you need to do some questions on your own. This is a unit that is traditionally a challenging unit for people, and a lot of these skills are things that you have to practice. You're not going to be able to just rearrange log equations without having ever done it, just watching people do it. At least the vast majority of people can't. So I've got some questions for you to try. Page 466 in your workbook, that's 7.7. 3 to 5, 6 to 11, 12 to 13. If you want to, try 15 and the multiple choice questions, but those are not mandatory. They're just extra problems for you. So I'm going to end the video here. Have yourselves a great rest of the day, and I will see you all tomorrow. Bye for now.